What's good, Logan? So coming at you with another video. This is how to graph a quadratic that's in vertex form. This question was specific for Mariana, and I just wanted to address it and make sure that you guys got it as soon as I can. So the first thing you're going to do is make sure you understand that it's a quadratic. That's step number one. You can tell it's a quadratic because it's a power of 2. So we know it's a quadratic. That tells us our graph is going to look like that guy right there. So this is where we understand, when it's a quadratic, we use the pattern over 1, up 1 on both the right and left, over 2, up 4, both right on left, over 3, up 9, both right and left, right? The reason that happens is because it's a quadratic power of 2. So we're going to multiply everything to the power of 2. So we start by finding the vertex. Now the vertex is located using that piece of number and that piece of information. Sorry, those two values. So our vertex in this problem is going to be located at -1, comma, -4. So we're going to make sure that when we graph it, it's at -1, -4. Second thing we're going to do is we make sure that we understand we're going to be using the parent function. So we start by drawing our x and our y axis. So now that we've got our vertex, we set up our x and y axis. And when we set up the y axis, I'm going to set it up so that it's mostly in the negative side. In other words, quadrant 3. For those of you who don't know what I'm talking about, quadrant 3, 1, 2, 3, and 4. Quadrant 3 is the one that most of this graph is in because of the -1, -4. So we plot that guy there, and we have our vertex. Now, after the vertex, normally what would happen is the graph would normally go right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4, right 3, up 9, left 3, up 9, right? But what we're going to do is not use these numbers explicitly, but use them with the 2/3 as well. So instead of going right 1, up 1, left 1, up 1, we multiply that by 2/3. So our first points, based upon these blue points on the parent function, we're going to go over 1, and instead of up 1, we're only going to go 2/3 of that. And that's approximately there and approximately there. Notice that it's on both sides. This is why we generally will draw an axis of symmetry. So we'll set up our axis of symmetry right through the vertex, the only point that is not reflected, and we're going to graph everything based upon that. Next, we're going to take a look at those green points. Now, these green points are located based upon going right 2, up 4, left 2, up 4. And that's what we're going to do. Instead of going up 4, though, we're going to use this multiplier. So we're going to take 2/3 and we're going to multiply it by 4 because that's how high we want to go. This is going to give us 8/3. 8/3 is going to be approximately 2 point something, 2.333 or 2 1/3. So now what we're going to do is we're going to go to the right 2 and not up 4, but we're going to go to the right 2 and up only 2/3 because we're going to shrink it. So we're going to take those green points and go up 2, right, and then up 2/3. So we're going to right 2 and then up, oh, that's a little bit lower than I'd like, up 2/3 on both sides of the axis of symmetry. And now normally I'd stop right here, but because this graph, because of the shrink of 2/3, I actually went out one more because of that value. And that value is when you go out 3, you go up 9. Now the reason I like this one is because the 2/3 cancels really nicely with 9. So I take the 2/3, multiply it by 9, and find out that we come out to just 6. So as I go to the right 3 spaces, I now need to go up 6 spaces. So that gives us that point right there. And then I can reflect across the across the axis of symmetry, and I have these 3 points. Connecting, 5 points. Connecting these 5 points, we get our quadratic, we get our parabolic curve that looks like that. Now, if you have any questions or you want to go through this a little bit more detail, please hit me up by email. Otherwise, I'll see you guys in class. See you later.